Hi folks. All right, so here's the last little bit of 5.4. So in this last part, we're going to take a look at applications of right triangle trigonometry. And hopefully this is something that we've seen before in the sense that we're looking at like when do we actually use trigonometry in real life, all right? So here's a pretty classic case. Example number 7. A 20-foot ladder leans against a building so that the angle between the ground and the ladder is 65 degrees. How high does the ladder reach up the side of the building? And how far does the bottom of the ladder from the wall? And so we're going to start very similarly for a lot of these problems, which is draw a diagram. Whoops. All right, so there's the wall. There's the ground. And we've got a ladder leaning against that wall. And the angle between the ground and the ladder is 65 degrees. So that means that our angle of perspective is really our theta is 65 degrees, okay? And we're talking about this angle down here. All right, what else can we label? Well, we know that the ladder is 20 feet long. And so we can say that the ladder, which is right here, is 20 feet long. Now, the question is asking us two different things. One is how high does the ladder reach up the wall? So like this part right here, like where's the top of the ladder hit? And it's also asking us how far the bottom of the ladder is from the wall. So like this distance. And I just chose X and Y because we're looking at a horizontal distance, so I call that X, and then we have a vertical distance, so I call that Y, okay? So let's find Y first, all right? So to find Y. Well, let's redraw our triangle real quick and see what we have. Ooh. So this is 65 degrees. This is 20. I know that this side is the opposite side. This is the hypotenuse, and this is the adjacent down here from my 65 degrees. And I'm looking for Y. So if I think about what trig functions I could use sine, I could use cosine, I could use tangent. And the trick is to choose the right one. Well, we have the hypotenuse and we want to find the opposite. So if I have SOHCAHTOA, which one of those three deals with the opposite and the hypotenuse? Well, that's sine. And so that's how I choose which trig function to use. So I'm going to set up my equation. Sine theta equals opposite over hypotenuse. Now let's fill in the numbers we have. Sine 65 degrees equals Y over 20. Okay. Now we're going to go ahead and solve for Y. So Y equals 20 sine 65. And now we can type this into the calculator. We want to make sure we're in the right mode, meaning if you changed it to radians earlier in class, we want to change it back to degrees. Otherwise, we're going to get the wrong answer, okay? So when we type 20 sine 65 into the calculator, we get 18.126 feet. All right, so that's how high up the wall the ladder reaches. Okay, now let's take a look at how far the bottom of the ladder is from the wall. So to find X, let's redraw this diagram real quick. I've got my 65 degrees, X, and 20. And let's see what we have this time. Well, we have opposite and hypotenuse and adjacent. And this time I have the hypotenuse. I want to find the adjacent. So that means I should probably choose cosine because cosine deals with the ratio between the adjacent and the hypotenuse. So then we set up our equation. cosine theta equals adjacent over hypotenuse. And we plug in the values we have. Cosine 65 equals x over 20. And to get x by itself, we're going to multiply both sides by 20. So we'll get 20 cosine 65. And when we type that into the calculator, we end up with 8.452 feet. Okay. Let's put that back on one screen for you. But a very classic case where we have a right triangle, we're trying to figure out some different side lengths here, and so we have to be able to choose the right trig function, sine or cosine or tangent, okay? All right, let's take a look at one more example. So in this example, we have the angle of elevation to the top of a building is found to be 24 degrees from a distance, from the ground at a distance of 6,100 feet. Find the height of the building. And so let's draw a diagram that represents the situation. So I've got a building. Whoa. I've got a building and the ground. And we know that the angle of elevation is sort of up from the horizontal, okay? So if you have a horizontal line, if you go up from this line, that is your angle of elevation. Whereas if you have a horizontal line and you go down from that, that will be the angle of depression, okay? So elevation meaning up and depression meaning down. And so when we look at this, the angle of elevation from the ground means that if we look all the way to the top of the building, that this angle is 24 degrees. Okay, so there's our theta. We found our theta, 24 degrees. Now, how far are we standing away from this building? Well, this is this part, and we're at a distance of 6,100 feet. Now, the question is saying, find the height of the building, which is this part right here, okay? So let me move this diagram so it's a little bit more central. Okay. Now, from our theta, let's label our hypotenuse, our opposite, and our adjacent. Okay. And let's think back to SOHCAHTOA, because we need to pick one of these to use. Well, it looks like we have the adjacent side and we want to find the opposite, so we're going to choose tangent. Okay. I don't have any information about the hypotenuse, and I don't want to find any information about the hypotenuse. So I can already eliminate sine and cosine, and that's another sort of reasoning why we might go with tangent. Okay, so tangent theta equals opposite over adjacent. Now we fill in our numbers. Tangent 24 degrees equals y over 6,100. Okay, now to get y by itself, we'll go 6,100 times tangent 24 degrees. And you'll notice that I'm like solving for y before I put it into the calculator, and I'd really like us to do the same thing too. Okay, we don't want to round too early, it just causes more inaccuracies. So the later we can wait to round, the more accurate our answers will be. And so now when you type this in, 6,100 times tangent of 24, that means that our building is 15.895 feet tall. Okay. So a good example of using tangent in a word problem, okay? And if you'll notice, the other example asked us to use sine and cosine. So again, as we're studying, let's really make sure we know which trig function to use when and how we make that decision, okay? All right, folks, so that's it for the last part of 5.4, and have a good rest of your day, and I will see you folks on Thursday for office hours if you want, or Monday for class. All right, bye.